Digitizing oscilloscopes have traditionally been thought of as simply two-dimensional instruments that display just volts versus time. But since the early days of analog oscilloscopes, two aspects of scope performance have been largely ignored. The first, referred to as a scope's third dimension, is the instrument's z-axis, which can highlight critical waveform information using display intensity gradation. A scope's fourth dimension, waveform update rate, can enable a scope to capture infrequent anomalies. Unfortunately, both of these dimensions were largely compromised when digital oscilloscopes began replacing their analog counterparts years ago. The good news is, Agilent's new 6000 series oscilloscopes with MegaZoom 3 technology are the very first digitizing scopes to exceed the display quality of traditional analog scopes by providing z-axis display intensity gradation, the third dimension. In addition, this new series of scopes provides the fastest uncompromised waveform update rates in the industry, the fourth dimension, up to 100,000 real-time waveforms per second. Let's now take a look at some real measurement examples and comparisons that demonstrate the importance of the third and fourth dimensions of oscilloscopes. Here we see displayed a one-time startup cycle of a motor drive signal using Agilent's new oscilloscope with MegaZoom display technology. This scope's intensity-graded display would be considered far superior to that of the analog display shown on the right, which shows nothing more than a flash of light streaking across the screen. And with the additional logic channels of this mixed-signal oscilloscope, we also have a clear view of critical digital control lines. Let's now zoom in on this stored waveform in order to better evaluate signal fidelity. This provides a much clearer view of the details of our signal. Notice the bright vector near the center of the screen, highlighted in the third dimension with intensity grading. This tells us something important about the signal. Thanks to its up to 8 million points of deep acquisition memory, this Agilent scope has revealed a signal problem, a small glitch, which is more clearly revealed by zooming in. Let's now compare Agilent's MegaZoom 3 display quality to another leading digitizing oscilloscope. Here, in this case, we'll show the same startup motor drive signal captured on a Tektronix TDS 3000 series oscilloscope. After zooming in on this stored waveform, we can see that Tek's 10,000 points of acquisition memory is unable to provide waveform details. This is in stark contrast to Agilent's MegaZoom 3 technology, which clearly displays superior results. This innovative display technology can also reveal valuable information about the dynamic nature in digital circuitry, such as jitter, noise, and infrequent events. For example, here on Agilent's MSO, we can see a digital pulse with noise riding on the top and base of the signal. But now look closer near the center of the screen. Here we see an occasional metastable state or glitch. The relative dimness of this glitch is an indication that it does not occur very often. By simply increasing the intensity of the display, we can view this infrequent glitch more clearly. This leads us to Agilent's fourth dimension performance capability, waveform update rate. Agilent's 6000 series oscilloscopes have the fastest, uncompromised waveform update rates in the industry today, offering up to 100,000 real-time waveforms per second, enabling you to capture extremely infrequent events without the need for select special acquisition modes that can contribute trade-offs. How then is this same infrequently occurring glitch handled by the Tek scope? Unfortunately, its update rate is too slow to reliably capture the glitch, even when using Tek's fast trigger mode, which limits memory depth and can reduce sample rates in many applications. If this scope user held a probe on the test point long enough, he might eventually capture the glitch, but not easily. He would be more likely to view the waveform for just a few seconds, see nothing abnormal, and then move the probe to the next test point, completely missing the infrequently occurring glitch. Agilent's 6000 series oscilloscope, with its fast waveform update rate, eliminates this uncertainty by quickly revealing this circuit's problem. But that's not all. Want to find out what might be causing this infrequent glitch? Using the additional logic channels that are seamlessly integrated into this mixed-signal oscilloscope, we set up a pattern trigger condition. This revealed that our system occasionally violated a critical setup and hold time specification due to clock jitter. So, when considering the purchase of your next digitizing oscilloscope, remember that uncovering complex analog and digital signal problems requires two additional oscilloscope dimensions beyond the fundamental ability to accurately display just volts versus time. Only Agilent's new 6000 series oscilloscope covers all four, including the highest quality displays of any oscilloscope on the market today, even exceeding the display quality of traditional analog oscilloscopes. Add to this the fastest real-time waveform update rates in the industry, up to 100,000 waveforms per second without compromise, enabling you to capture and see very infrequent anomalies. Combine these powerful capabilities with the triggering and display advantages of a mixed-signal oscilloscope, and you have the most performance and versatility available in a digitizing oscilloscope, with bandwidths ranging from 300 MHz up to 1 GHz. For additional information about Agilent's new 6000 series oscilloscopes, go to www.agilent.com/find/MSO6000. And for more detailed information about the two measurement applications illustrated in this video, download Agilent's application note number 1551 and application note number 1552.